day, the Earth spins on its axis, and the Hub delivers you new and exciting content to make you think about the world around you. And what a world it is! Whoever our real estate agent was 4.5 billion years ago, he, she, or it gave us the deal of a lifetime. Yes, the luck of our existence is due to our planet's location, physical makeup, and other unique factors. We've had ups and downs, we've seen our fair share of disasters and natural wonders, and the Hub has curated many of these strange and interesting instances into 10 facts about the Earth you didn't learn in school. So breathe in the oxygen, drink the refreshing water, and appreciate how you're evolved enough to enjoy a video about the mysterious and fantastic planet on which you live. And remember, the Hub will keep spinning news as fast as the Earth revolves, so just click subscribe to stay in the know. I am your density. In our solar system, Earth is one of the smaller planets around. But did you know that it's the most dense of all the celestial bodies orbiting our sun? And that's not because our fattier foods are weighing the planet down. The terrestrial planets, the 4 rocky spheres orbiting closest to the sun, are all denser than the 4 outer gas giants. If Saturn were placed in a big enough glass of water, for instance, it would float. It should be noted that Mercury, while much smaller in size than Earth, is the second most dense planet in the system. Due to Mercury's proximity to the sun, gravitational compression plays a factor in that planet's density. Uncompressed, Mercury would be denser than Earth due to its massive core of iron and nickel. These two elements play an important part in shaping our density as well. Our inner and outer cores are composed of them, and it's believed that our outer core spins in an opposing direction to the Earth's rotation, generating our planet's magnetosphere. Speed Demon. Considering how quickly we're rotating and revolving, it's amazing that we can still drive safely through the cosmos. We've had major impacts with comets and asteroids, but Earth is still going strong. While we probably have a great space insurance plan, let's hope our rate hasn't increased due to any speeding tickets. I mean, we are traveling at 67,000 miles per hour around the sun, but that doesn't account for how fast everything is moving. If you were at the North or South Pole, you wouldn't spin at all, since the axis is on the hinge in which our world turns. On the equator, though, your body is strapped by gravity to a part of the Earth that is turning at a rate of about 1,000 miles per hour. Don't get space sick just yet, though, because our whole solar system is rotating around the Milky Way galaxy at 490,000 miles per hour. And the Milky Way, along with all the other galaxies around us, is rushing away from the Big Bang's origin point at a rate of 621.4 miles per second. Apparently, we're heading towards a mysterious place called the Great Attractor that's about 150 million light years away. Why we're in such a rush to get there is anybody's guess. The poles are open. Earth spins around the geographic north and south poles, which more or less stay in the same general location. However, the exact coordinates of our magnetic north and south poles are changing every day due to any number of factors like the rotation of our planet's core, the radiation and energy in the magnetosphere and ionosphere, and whatever mood the poles may be feeling on a given day. On average, the pole will move 10 kilometers overall per year, and within this movement, it can vary its location on a daily basis within a radius of 80 kilometers. Thankfully, modern GPS technologies allow our navigation systems to adjust and reorient to wherever the poles are in a given period, but feel free to use this as an excuse whenever you're driving in late to a meeting. Start wearing purple. If you think it's weird that our poles are as unpredictable as the poles for the 2016 election, then think about this. Modern science suggests that early plant life was purple. That's right, our green planet was once as violet as a glass of grape soda. Chlorophyll, which is what plants use to absorb sunlight for energy, reflect green wavelengths, allowing us to see green as the chief color of plant life. When you consider that most of the sun's healthy radiation comes to us in the form of green wavelengths, you'd think plants would have evolved to absorb green and reflect the blue and red wavelengths. Well, scientists have thought this as well, and they theorize that there once was a rival to chlorophyll in ancient times, and it may be the plum-colored retinal molecule that we see in purple organisms today. Specialists with opposing views argue that plants don't absorb green light in order to protect themselves from overexposure to the sun's energy, but an entirely purple world is fascinating to imagine. It would also have made it easy to find floral decorations for a party at Prince's house. Water, water everywhere. One color we still see a lot of is blue, but most of the world's fresh water is concentrated in one place, Antarctica. Our southernmost continent contains a whopping 70% of fresh water and 90% of Earth's total ice content. The other 10% is in the north, in Greenland's ice sheet. Up here, it's so densely compacted that the ice's thickness is generally 5,000 feet deep. But that's just the average. Some places contain a depth of up to 14,000 feet. Overall, 1.7% of all water on Earth is frozen in ice, but that 1.7% accounts for nearly 3/4 of all the world's freshwater content. If you don't live in a desert, you might take water's abundance for granted. But if all the glaciers were to melt tomorrow, you would be happy you invested in all those stocks in the water bottle company. Oceans, the final frontier. All this concerning talk about our planet's water, and yet we barely know our own oceans. Although 70% of Earth is covered in water, we've only really explored a small percentage of it. Much of the depths of the Atlantic, Pacific, Indian, and Arctic Oceans remain uncharted. But that doesn't mean we haven't looked at the big picture. With satellite imaging, we have managed to map all features of the ocean floor that are 5 kilometers or more. Basically, we know the location of major geological features, and that's it. Since satellite radio waves were obstructed by ocean water, our best bet for detailed mapping of the rocky surfaces at the bottom of the sea is to rely on the sonar of ships. Unfortunately, this method only gives us a more intricate view of the strip of land directly under the moving boat and has allowed us to get detailed views of only about 10 to 15% of the ocean floor. In that respect, we have more knowledge about the surface of Mars and Venus than our own seabed. Blue Gold Rush. Cartographers' mappings of the ocean floor would help miners as well. Apparently, there is enough gold down there to fill the pockets of every single person on Earth with $21,000. Initial mining endeavors would be handled by remotely operated vehicles, but eventually floating platforms would be placed above mining sites with conveyor belts, transporting materials from the ocean floor to the surface. If this gets too complicated, maybe they'll find a way to extract the material directly from the seawater. In fact, each drop of water is a tiny, tiny gold mine. Outside of what's embedded on the ocean floor, each liter of salt water has within it 13 billionths of a gram of diluted gold. So, if you want to get your significant other something fancy for your anniversary, drive to your nearest beach and fill up a jug. Like a rock. Moving on to one of Earth's drier climates, a mystery in Death Valley has confounded scientists for several generations. In the dried-up lake bed of this desert terrain, rocks weighing up to 600 pounds have been found to move overnight, leaving tracks in the dirt behind them. What could cause such movement? Dust devils? Gale force winds? Aliens? Brothers and fellow scientists Richard and James Norris discovered that ice, frozen to the surface, following a rare night of rainfall, would eventually break up, cling to the bottom of the rocks, catch wind, and act as sails, pushing the rocks along the desert floor at an average of 15 feet per minute. It's a rare event that requires several factors: rainfall, freezing temperatures, an appearance by the sun to break up the frozen ice, and a thin layer of remaining rainwater on which the ice can act as a sail, moving the rocks. Even though the rocks float across the desert very slowly, they bring some much-needed liveliness to Death Valley. Fungus for all of us. With elephant tongues, hearts weighing as much as Buicks, and bodies the length of 2 or more school buses, blue whales are the largest animals around. But what if there was an even bigger living thing around today? And what if that organism was nestled right in America? Deep in the Malheur National Forest of eastern Oregon, a 2,400-year-old fungus has stretched its roots through 2,200 acres. This Amylaria ostoyae started as a microscopic spore and has thrived in Oregon's dry climate. It was found when scientists were investigating the larger-than-usual number of dead or dying trees in the area, mostly underground. The physical evidence appears when small golden mushrooms pop up through the soil. The good news? They're edible. Whale watching may provide more excitement than fungi watching, but if you ever want mushroom stuff with history, head on over to Oregon. One Earth isn't enough. But enough about us. While our own planet is full of infinite wonders, we may eventually run out of natural resources. Forced to transition from space exploration to space migration, we'll want to settle on a place like Earth. Although NASA assumed we'd eventually come across planets outside of our solar system, it wasn't until 1995 that the first exoplanet was discovered. Beyond that, we had to wait until earlier this year before NASA could confirm the discovery of the largest group of potentially Earth-like satellites orbiting an ultra-cool dwarf star, referred to as TRAPPIST-1. 3 of the 7 newly located planets are in the just right Goldilocks zone, where life could thrive. The difference between our solar system's habitable zone and the TRAPPIST is that their star is much smaller and cooler than our own, allowing the potential for organisms to survive in a location much closer to their sun. Over the next 10 years, NASA experts, coupled with satellite analysis, will research the atmospheres, climates, and gravitational signatures of these planets to learn if they're suitable for life. At only 40 light-years away, we may be able to visit this place, say, 3017. Stay healthy so you can tell all the beings on TRAPPIST about the beauty of a small blue planet in a solar system not too far away that has wide oceans, deep forests, and an internet that gave you access to videos like this one. We hope you enjoyed these